Hey everyone, it's Miss Gubrud. Welcome to Lesson 8. We're going to find out how to find the areas and also the perimeters of regular n-gons. And now you might be saying, what does that even mean? The word regular in this particular case means all the sides are the same, all the angles are the same. So it means a shape like you expect to see a shape. So like a pentagon is like a pentagon that we're used to seeing. A hexagon, a hexagon we're used to seeing. An octagon we're used to seeing, where all the sides are the same and all the angles are the same. The N just means that it could have any number of sides or the name of a polygon. So we're going to find the areas of regular pentagons, the areas of regular hexagons, the areas of regular octagons. We could even do to like dodecagons. So n-gons means any polygon that has a sort of a regular way we see it. Doesn't matter what the number of the sides is. So you'll get not to worry, you'll figure it out. You'll get the hang of it as we go along. So please, if you don't have your book with you, pause the video, open up your book to page 83 and 84. All right, here we are. We're on number 1, Unit 2, Lesson 8. And the question starts out, this is the question you're going to ask yourself over and over as you think about these n-gons, these different kinds of polygons with the same size sides. So take a look at this pentagon here. There it is. Now this pentagon, all those sides are the same, and all the angles inside are all the same. So remember how we could show that is we could put a little slash across, because those little slashes tell us all those sides are all the same length. Now, the question though is, when we're dividing this up, we're going to treat it like a complex shape. We're going to cut it up. And in this particular case, we're going to cut it up into as many triangles as there would be bases or outside sides. So this is a pentagon, so it has 5 sides, so we're going to cut it into 5 triangles. How are we going to do that? The key is the little tiny dot in the very center. This dot right here, we're going to put a dot right in the very center of the shape, and then we're going to connect all of the corners, all of the vertices to that dot. So start over on this corner right here and draw a line straight in to that dot. Then go to the next corner right there and draw a line straight in to that dot. Again, next corner. Notice we're not starting on any of the flat sides. It's all corners. And we go straight in to the dot. Next corner right here. There it is. Straight into the dot. And last corner right there, straight in to the dot. Have you been doing that along with me in your book? If you have, you're in great shape. Keep going. If you haven't, pause the video. Do exactly what I just did right there. Draw that in your book and then come back. All right, let's take a look at number 1. How many same size isosceles triangles are in the regular pentagon? Remember, we said the number of triangles that are in it are the same number of sides that are in it. So that's 5. There's 1, 2, 3, 4. Don't let that one trick you. It's just showing the height. 5. Now it says measure the base and the height to the nearest centimeter. We actually have to take out our ruler and measure this. So go grab your ruler, pause the video, go grab your ruler, and let's measure. All right, I've got my book here. I've got my ruler. Remember, you need to look and make sure that you're looking at the small numbers, the centimeters, rather than the larger numbers, the inches, because this tells us to measure in centimeters. So I put it up right there. The base is 4. Now, how many times do I have to measure the base? Do I have to go and measure this one and this one and that one and that one? Do I have to measure all those? No, because the definition of a regular engon, in this case, a regular pentagon, is that all of the sides are the same. So if I measured one and it was 4, I know this one's also, whoops, I was writing 5 there. That was weird. I know this one is also 4. And I already indicated that with my little line there, didn't I? I know this one's also 4. I know this one's also 4. And I know this one's also 4. But I do need to measure the height. This is the part that tricks kids on this. The putting the dot in the center usually doesn't trick kids. The drawing the lines from the corners usually doesn't trick kids. It's the height. Where is the height on this shape? The height goes from the outside base straight up to the center dot. But it doesn't come off the vertex. It has to go perpendicular. Remember, it has to be in the shape of a T. So it starts in the middle and goes from the middle of the base straight up to the dot. So that's where we're going to measure. We're going to measure from the middle of the base straight up to the dot. It's almost exactly 3. So let me grab a different color here. This height is 3. Now, what's the height of the other ones? I hope you know the height of all those is 3 as well. We only need to figure out one of these triangles, and we can figure out the area of the whole thing. So here we go. Measure the base and the height. We've done that. Number 3, use your measurements for base and height to find the area of the triangle. We know the area of a triangle. Write this with me. If you don't have this, if you don't know this, pause and think about it. Pause this, write that. Well, how do we find what's the formula for an area of a triangle? Pause and come back. All right. I hope you said the area of a triangle is a half of the base times the height. 1/2 of a group of the base times the height. So we know that the base in this case is 4. We know that the height in this case was 3. We need to cut that in half. That's what I'm writing. Remember, the fraction bar can also be used as a dividing bar. So 4 times 3 is 12. Cut in half is 6. So I know that one of these triangles, I'm going to use this one down here, just because that one, it's easy to see the base, if I can color that in a little bit. So that one triangle right there, triangle number 4, how I label it, for triangle number 4, that one, the area is 6 square centimeters. What do you think that means for the area of the whole pentagon? Pause and see if you can figure that out. All right. I hope you said, well, if I know 1 is 6 and I have 1, 2, 3, 4, 5 exactly like them, they're exactly the same. I hope you knew we could multiply the number of the engon, in this case, the pentagon, penta means 5. So we could multiply the number, the 5, times the number that we know it is on one of them, 5 groups of 6 centimeters squared. And I hope you knew we would get 30 square centimeters. So we only need to do the work one time, and then we figure out how many of those we need to solve the problem. That's the whole essence right there. That's the whole essence of how to find the area of n-gons. It doesn't matter if the n is 5 for a pentagon, if the n is 6 for a hexagon, if the n is 8 for an octagon, we still solve all of these same questions the same way. All right, let's go on to number 5. Number 5, we have to measure as well. Now, we're going to have to measure the base, and then it also shows us the height. This is an engon, but there are 6 regular sides, so it's a hexagon. So the very first thing they do, remember, is they put that dot right in the very center of the engon. There's the dot. And then they mark straight from the corner, straight to the dot. They go from the next corner, straight to the dot. They go from the next corner, straight to the dot. They go from the next corner, straight to the dot. They go from, whoa, I'm throwing my pen. They go from the next corner, straight to the dot. So that we've marked out 6 exactly the same triangles. All right, now we need our ruler again because we've cut our engon, our hexagon in this particular case, into 6 exact isosceles triangles. We need to measure the base of only one of them. We'll just use that over and over again. When I measure it, I get a little bit less than 4, but let's just call that 4. We'll round it to 4 because it's pretty close for mine. So let's call it 4. The base is 4. Now, when I measure the height, my height is pretty close to 3 as well. It's not quite 3, but my height is pretty close to 3. So there is I'm looking at just this one triangle right here with the whole base. Don't let that height dash line trick you. This is the triangle right there, and it's the base of 4 and the height of 3. Now, how are we going to find out the area of the whole thing? Well, we know this area right here, all of this, 4 times 3 is 12, but that's for a rectangle. For a triangle, we got to cut it in half. So 4 times 3 is 12. Cut in half is 6. So we know this area right here is all 6. Let's figure out then, what would that mean for the whole thing? I'm going to pause, and on my computer, I'm going to draw those lines from the corners, from the vertex to the center, from the vertex to the center. If you haven't done that yet, pause and do that too with me. All right, here we go. I start at the vertex and I go straight to the center. Start at the vertex and go to the center. How many of those little triangles did I make? It's the same number as the number of sides. So I made 6. So there's 1, 2, 3, 4, 5, and this one is number 6. Now I already found out that one of my triangles has the area of 6 square centimeters. In this case, there's 6 sides, so there's 6 groups. For this engon, there's 6, and the area of one is 6 centimeters. So we've got 6 times 6, and that is 36 square centimeters. Remember when we say square centimeters because it's the amount that covers over. Area alien comes down, spreads all out and covers that whole area. And it's how much is covered, how many little squares is covered, and we write that with that little 2 up above. So 36 square centimeters. All right, let's go on to number 6. The height of the triangle is rounded to the nearest centimeters, and find the measurements. Now, this one you're going to do on your own exactly like we just did number 5, but it's not drawn to scale. Don't let that trick you. That means when you look at it, you might say, wait a minute, that is not 12 centimeters. I just was using my ruler, and my 12 centimeters is this big on my ruler. That is not how big that size is. It's okay. They're just showing it smaller, but they tell you the dimensions anyway. So don't let that throw you off. It's not actually 12 centimeters, but say we're pretending this is 12, and same with the height. we're pretending the height is 10. Go ahead and solve number 6 on your own and then come back and see if we agree. So pause and go do it and then come back. All right, 12 times 10, base times height is 120. Cut that in half, it's 60. So this one triangle down on the bottom is 60. That's right there. That's 60 square centimeters. But there's 6 of them. They're all the same. I don't need to do base times height every time. I just know it's the same. So there's 6 groups of 60 for 360 square centimeters. Okay, let's go on to page 84, and we're going to start looking at octagons. So here's the octagon. Octagon, octo, oct means 8. Remember, it's like an octopus. So there's 8 corners and there are 8 sides. So the question says, how many same size isosceles triangles? Remember, anytime we have a regular n-gon, a regular gon that has the same all around, no matter how many sames there are, we're going to call that some kind of an n-gon because n is an unknown number. And remember, the very first thing we're going to do is put that dot in the center. And then we're going to draw those lines from all the vertices, all the corners. We're going to draw those lines in. So take a look at the picture and go ahead and do that with me. In your book, again, put that little center dot in there. Start by putting that center dot right in the center. It doesn't have to be giant. It doesn't have to be small, but also don't make it like really big. Make it just kind of a little dot in the center. And then take every corner and draw a line straight in. Go to the next corner, draw a line straight in. Go to the next corner, draw a line straight in. Pause and do that. Do the whole thing and then come back. All right. So how many isosceles triangles did you make? Well, remember, the number of triangles matches the number of sides there are. So if this is an octagon, oct means 8. If there are 8 sides, that means there are 8 triangles. There's 1, 2, 3, 4, 5, 6, 7, 8. Now, number 8 says, what is the area of the whole thing? How are we going to find it? We're going to find the area of 1, and then we're going to extrapolate. That's a fancy word that means figure out from there. Use our information and figure out. So we see that this one right here has a base of 4 and a height of 5. We know that the area of a triangle, the formula is base times height cut in half. So we know it's going to be a half of 4 times 5. There it is. We know 4 times 5 is 20. A half of that is 10. So we know that there is 10. This is 10 right here. That one right there is 10. Are we done? We're not done. Pause and see if you can figure out if one of those triangles is 10, what is the whole hexagon? Pause and figure it out. All right, you knew there were 8 triangles. There are 10, each one is 10 square centimeters. So 8 times 10 is 80 square centimeters. Now, what do you notice about the number of sides and the number of isosceles triangles? We've talked about this a few times in this video. Write the answer down. What is that? The number of sides, how many triangles you get. Pause and write that down. Okay, of course, I hope you knew that. They're the same. The number of sides on a regular n-gon tells us the number of little triangles in that n-gon. If there are 6 sides, there's 6 triangles. If there's 8 sides, there's 8 triangles. If there are 22 sides, there are 22 triangles. Number 10, what formula? Remember, when we're talking about a formula, it has letters in it because it can work for any size, any type of that particular problem. So it says, what formula could we write for the area of a regular octagon using S as the side length. There's that letter. It doesn't tell us the number, how long the side length is. That's letter S. It tells us it has S, that's the length of the side, and H, that's the length of the height. So we know that the formula for a triangle is base times height. They're using S for side times height. But then we can't forget it's a triangle, so we have to cut it in half. So we've got a triangle is a half a group of, in this case, we would usually call it base times height, but they want us to call it the side. And I know that's hard. It looks like a 5, but it's not. It's an S, side times height. But now it's not just one triangle we're figuring out. The question says, what formula could you write for the area of a regular octagon? So how many half times side times heights do we need? It's an octagon. We need 8. So we're going to put parentheses around because we know we do that part first. And then we're going to say times 8 groups. We need 8 groups of that. Remember, when a number and a parenthesis are stuffed right next to each other, there's an imaginary multiplication sign in there. So 8 parenthesis, a half times the side times the height, means 8 times that, 8 groups of that. So there is the formula. 8 groups of 1/2 a group of the side times the height. Now, notice that I scribbled out this picture. Go ahead and just cross that picture out. It's just too confusing for us right now. That's not what we're thinking about right now. So go ahead and cross that out. Same thing with number 11. You notice I just put a little squiggly line to it. Don't do number 11. Go ahead and skip that number. Now, number 12, again, take that picture out. We want to think about the formula, but that picture isn't helping us. So let's look at number 12. What formula could you write for the area of a regular pentagon using S as the side length and H as the height? Pause and see if you can figure it out. We just did it with octagon. It has 8 sides. Now they're asking us to do it with pentagon with 5 sides. Pause and see if you can figure that out, and then come back. All right. I hope you notice it looks a lot like our answer number 10. Instead of starting with 8 groups of, we need 5 groups of, because a pentagon has 5 sides. That means it has 5 triangles in it. So it's 5 groups of the base, which we're calling side, times the height, cut in half because it's a triangle. So 5 groups of a half times the side times the height. Now, this is all leading up to number 13. It is the formula for a regular n-gon. We can write a formula that works for no matter what kind of gon it is. A pentagon, a hexagon, an octagon, a nonagon, a decagon, a dodecagon. Doesn't matter. It could have 100 sides, which I actually don't know the name of, but it could have 100 sides. It doesn't matter. We're going to write a formula that will work for every single regular gon shape in the whole world all the time, no matter the size, no matter the number of sides. How are we going to do it? Well, let's start by looking at the similarities between the octagon in number 10 and the pentagon in number 12. Notice that they both have a half group of the side, how the length of the side, times the height. We could call it the base if that's easier for you, but you can call it the side. I'm going to actually change and use the base because that's something we've been using for triangles. The base of the triangle times the height of the triangle. So I'm going to start by writing base times height. Now, we know the base times the height gives us an area of a rectangle. So what are we going to do? I'm going to do a half of that. You could either write it like we did up here with 1/2 group of, or you could also put cut in half, divide by 2. Remember that fraction bar means a division bar. So base times height cut in half. So that is one triangle, base times height cut in half. Now, how are we going to tell that we need a certain number of groups of those? If it's a pentagon, we need 5 groups. If it's a decagon, we need 10 groups because decagons are 10 sides. If it's a dodecagon, we need 12 groups. So the question is, we can't write the number 6 and the number 8 and the number 10 and number 12. That's why we call it an n-gon. We're going to use the letter n to mean a number that could be any number, the number that we don't know. So we're going to say n times n, meaning any number that we can put in there, however many sides there are, that's n, times 1/2 of the base times the height of one of those isosceles triangles. So n times base times height cut in half. Now, if you want to stick with the sides that they've been using, you could say n times, we'll keep the pattern going, a half group, I'll put parentheses in here, a half group of side times height. I just don't really like using side because it looks so much like a 5. Sometimes it gets confusing. Kids sometimes think there's a 5 in there. There's not a 5 in there. It just looks like it. Good luck with this. Good job today. We're all done. We got all the way through the whole lesson. Go and do some freckle to practice at your level. See you next time.